Hello viewers, in this video I'll discuss the properties of definite integrals. Using these properties we will evaluate some definite integrals. Here I will also discuss how to find definite integral of modulus function. So first we will see the properties of definite integrals. The first property, integral a to b f of x dx is equal to integral a to b f of t dt. That is, if we change the function x to t, the definite integral remains the same. Integral a to b f of x dx is equal to integral a to b f of t dt. Here we can easily see that if we substitute x as t, then we will get the same value. Then the second property is integral a to b f of x dx is equal to minus integral b to a f of x dx. That is, here when we change the limits, when the upper limit becomes the lower limit and when the lower limit becomes the upper limit, then the sign of the definite integral changes. So we have integral a to b f of x dx is equal to minus integral b to a f of x dx, and in particular integral a to a f of x dx is equal to 0. Then the next property is integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. If we have c in the interval a comma b, then we can write integral a to b f of x dx as integral a to c f of x dx plus integral c to b f of x dx. Then the next property is integral a to b f of x dx is equal to integral a to b f of a plus b minus x into dx. We'll continue with the properties. The next one is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x into dx. So these two are equal. Then the next property, integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x into dx. Now if we have this integral f of 2a minus x equal to f of x, then we have integral 0 to a f of x dx equal to 2 times integral 0 to a f of x dx. And if this f of 2a minus x is equal to minus f of x, then these two will cancel out and we get equal to 0. So in that case, integral 0 to 2a f of x dx equal to 0. That is when f of 2a minus x is equal to minus f of x. Then the next property, integral minus a to a f of dx is equal to 2 times integral 0 to a f of x dx if f is an even function. Even function is nothing but if we have f of x is equal to f of minus x, then such functions are called even functions. Say for example, if we take f of x as x square, then it is equal to minus x the whole square. So here f of x is equal to f of minus x. So x square is an even function. So if f is an even function, integral minus a to a f of x dx equal to 2 times integral 0 to a f of x dx. On the other hand, if f is an odd function, that is, odd function is nothing but f of minus x is equal to minus f of x. Say for example, x cube. If we take f of x as x cube, then if we substitute x as minus x, then we have f of minus x will be minus x the whole cube. It is minus x cube, or it is equal to minus f of x. So in this case, the function x cube is an odd function. In that case, integral minus a to a f of x dx equal to 0 when f is an odd function. Now we will see some problems where we can use the properties of definite integrals and we will evaluate the definite integrals. We will also see how to evaluate definite integrals of modulus functions. The first one is integral minus 5 to 5 mod x plus 2 into dx. Now this modulus function, we know that when we have this modulus function mod x plus 2, it means x plus 2 is, it is less than or equal to 0 on the interval minus 5 comma minus 2, and it is greater than or equal to 0 on minus 2 comma 5. So what we can do? The modulus function, it is nothing but here we have the interval from minus 5 to 5, the limits from minus 5 to 5. We cannot directly integrate this modulus function, we can only integrate polynomial functions. So what we have to do? We have to, by definition of the modulus function, we have to divide the limits. So here we can see that x plus 2 will be less than or equal to 0 on this interval minus 5 to minus 2, and x plus 2, and it will be greater than or equal to 0 on the interval minus 2 to 5. So using this property, greater than or equal to 0. So using the property integral a to b f of x dx equal to integral a to c f of x dx plus integral c to b f of x dx, we can write integral minus 5 to 5 mod x plus 2 dx is equal to integral minus 5 to minus 2 mod x plus 2 dx plus integral minus 2 to 5 mod x plus 2 dx. So using this property, we can write this integral minus 5 to 5 as integral minus 5 to minus 2 mod x plus 2 dx plus integral minus 2 to 5 mod x plus 2 dx. Now if we consider a number line, here we have, let us say, minus 5, then minus 2, and let us say 5 here. Now in this interval, we can see that x plus 2 will assume negative values in this interval. When we substitute any value for x in this interval, say minus 3 or minus 4, we will have negative. So this is equal to minus integral minus 5 to minus 2 x plus 2 dx plus in the interval minus 2 to 5, if we substitute any value for x, it will be positive. Say for example, if we substitute minus 1, then the value for x plus 2 will be positive. So in this interval, it is positive. So integral minus 2 to 5 x plus 2 into dx. So this is equal to minus, now we know how to integrate integral x plus 2 dx. It is nothing but it is x plus 2 the whole square by 2 with the limits minus 5 to minus 2 plus x plus 2 the whole square by 2 from minus 2 to 5. So this is equal to, here when we substitute the upper limit, we get minus 2 plus 2 by 2, so it is 0. Then minus of minus is plus. When we substitute the lower limit, x plus 2 the whole square. When we substitute the lower limit, we get minus 5 plus 2, it is minus 3. So minus 3 the whole square is 9 by 2. Then here when we substitute the upper limit, when x is equal to 5, we get 5 plus 2, 7 square. So it is 49 by 2 minus, when we substitute the lower limit, minus 2 plus 2, it will be 0. So this is equal to 58 upon 2, which is equal to 29. So integral minus 5 to 5 mod x plus 2 dx is equal to 29. So this is how we have to use the property to find integrals of modulus function, definite integrals of modulus functions. The next question, integral 0 to 1 x into 1 minus x the whole raised to n into dx. Let us take this as equal to I. Now let us use the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So using this property, here in place of a we have 1. We will substitute f of 1 minus x into dx. So in place of x, let us substitute 1 minus x. So what happens is we get integral 0 to 1, 1 minus x into 1 minus of, here in place of x we are substituting 1 minus x. Here in place of x, let us substitute 1 minus x. 1 minus of 1 minus x the whole raised to n into dx. So this is equal to integral 0 to 1, 1 minus x into 1 minus 1 plus x the whole raised to n into dx. So 1 minus 1 will go. So this will be equal to integral 0 to 1, 1 minus x into x raised to n dx, or it is equal to integral x raised to n minus x raised to n plus 1 dx from 0 to 1. Now it is very easy. We can use the standard integrals. Integral x raised to n dx is x raised to n plus 1 by n plus 1. Then minus integral x raised to n plus 1 is x raised to n plus 1 plus 1. So it is x raised to n plus 2 by n plus 2 with the limits 0 to 1. Now substituting the upper limit, we get 1 by n plus 1 minus 1 by n plus 2. Then substituting the lower limit, it is 0 minus 0. So it is 0. So taking the LCM as n plus 1 into n plus 2, the numerator we get n plus 2 minus n minus 1 divided by n plus 1 into n plus 2. So n and n will go, 2 minus 1 is 1. So this is equal to 1 by n plus 1 into n plus 2. So this is how we can use the property of definite integral and find the values of such integrals easily. The next question, integral 2 to 8 mod x minus 5 dx. So let us take this as equal to I. Again, if we consider this function, we can see that x minus 5, it is less than or equal to 0 on 2 comma 5. On this interval, x minus 5 is less than or equal to 0 and it is greater than or equal to 0 on the interval, closed interval 5 comma 8. So using the property integral a to b f of x dx equal to integral a to c f of x dx plus integral c to b f of x dx, we can write integral 2 to 8 mod x minus 5 dx as integral 2 to 5 mod x minus 5 dx plus integral 5 to 8 mod x minus 5 dx. Now if we consider the number line, we have 5 here, 8 here, and let us say 2 here. So if we consider the function x minus 5 in this interval from 2 to 5, it is negative. So x minus 5 is less than or equal to 0 on this interval 2 to 5. So this will be equal to minus integral 2 to 5 x minus 5 dx. Then in the interval 5 to 8, x minus 5 is greater than 0. If we substitute any value, say 6, it is going to be positive. So in this interval 5 to 8, x minus 5 is greater than or equal to 0. So plus integral 5 to 8 x minus 5 dx. Now we know how to solve this. Integral x minus 5 dx is x minus 5 the whole square by 2 with the limits 2 to 5 plus x minus 5 the whole square by 2 with the limits 5 to 8. Now if we substitute the upper limit, we get 5 minus 5 the whole square by 2, it is 0. So minus 0 plus, when we substitute the lower limit, we get, here in place of x we have to substitute 2. So 2 minus 5 the whole square is minus 3 the whole square. So it is 9 by 2 plus, here when we substitute the upper limit, we get 8 minus 5 the whole square by 2. So it is 3 square by 2 or 9 by 2 minus, when we substitute the lower limit, 5 minus 5 is 0. So it is 9 by 2 plus 9 by 2. So it is equal to 9. The next question, integral minus 1 to 1 x raised to 4 plus x square into dx. So if we consider this as f of x, f of x is equal to x raised to 4 plus x square. Then f of minus x is equal to minus x the whole raised to 4 plus minus x the whole square. So it is again equal to x raised to 4 plus x square. It is equal to f of x. So f of minus x equal to f of x implies f is an even function. So using the property integral minus a to a f of x dx equal to 2 times integral 0 to a f of x dx. If f is an even function, we can find this as integral minus 1 to 1 x raised to 4 plus x square into dx equal to 2 times integral 0 to 1 x raised to 4 plus x square into dx. Since this function x raised to 4 plus x square is an even function, so this is equal to 2 into, now we know how to evaluate this integral. Integral x raised to 4 dx is x raised to 5 upon 5 and integral x square dx is x cube upon 3. So this is equal to 2 into 1 by 5 plus 1 by 3. Upper limit is 1 minus lower limit is 0. So it is equal to 2 into, so when we take the LCM is 15. So it is 3 plus 5 upon 15, which is 8 by 15. So this is equal to 16 by 15. So integral minus 1 to 1 x raised to 4 plus x square dx is equal to 16 by 15. The next question, integral minus 8 to 8 x cube dx. Here if we take, let f of x is equal to x cube, then f of minus x will be minus x the whole cube, or it is equal to minus x cube. So it means f of minus x is equal to minus f of x. This is equal to minus f of x. So which means f of x is an odd function. So here integral minus 8 to 8 x cube dx can be calculated using the property integral minus a to a f of x dx equal to 0 if f is an odd function. So here we got f of minus x is equal to minus f of x. Therefore, x cube is an odd function. So using this property, we can see that integral minus a to 8 x cube dx equal to 0. The next question, integral 0 to a root x upon root x plus root of a minus x into dx. So here let us take, let I is equal to integral 0 to a root x upon root x plus root of a minus x dx. Let us mark this as equation 1. So let us use this property, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x into dx. So we will write the same integral using this property. So the same integral I is equal to integral 0 to a f of a minus x. In place of x we have to substitute a minus x. Root of a minus x upon root of a minus x plus root of a minus x into dx. So let us mark this as equation 2. Now when we add 1 and 2, the left hand side we have I, so I plus I will be 2I. So 2I will be equal to integral 0 to a root x upon root x plus root of a minus x plus, I am writing this. So this is root of a minus x upon root of a minus x plus, here root of a minus x is a minus a plus x. So these two a will go. So it is root x into dx. So here the denominator is the same. It is root x plus root of a minus x. So the LCM is the same. So we can add the numerator. So this is equal to integral 0 to a root x a minus x divided by root x upon root a minus x. Here adding 1 and 2 into dx. So these two will cancel out. So this is equal to integral 0 to a dx, or it is equal to x with the limit 0 to a. So this is equal to a. We got 2I is equal to a. So from this we get I is equal to a by 2. I is nothing but it is the given definite integral. So we used this property and we were able to find this integral very easily. I hope this video was useful for you. Thank you for watching.